Okay, then let's get rolling. Thanks everybody for coming. This is another episode of our HDF Clinic. First of all, I would like to thank my colleagues, Scott, Alexander, and John, for stepping up and sort of hosting the last 3 clinics. And I think, the recordings are available on YouTube now. And actually, I watched them already, and I think there's some fantastic content there. And we definitely want to do more of this and diversify and to really address a wider audience rather than just developers or people who follow the forum, and just offer more practical advice. And then it was so interesting to hear when, I believe last week, John had Karim, and so they were working through some HSDS issues and so forth. That was really, that's the way it should be. And so I'm glad things are coming together. Okay, I jumped already into announcement. Are there any questions? I looked at our cheat sheet. There weren't any there. So are there any other questions at the moment?
No, Gerd.
Okay, thanks. And then, jobs, the job postings are still out there. If you know someone, send them our way. And we are looking forward to sort of getting a lot of resumes and then hiring people. Okay, so for me this week was really catching up on the forum, and as always there were interesting discussions and so forth, and subjective collection. I just picked out what stood out to me. There was this whole thread, and I see there were some updates, something that I just misunderstood in the beginning, around size T versus H size T, and size T being a C type and H size T being an HDF5 API type. And then there seems to be inconsistent use of sizes of size T or H size T. And then, I sort of just looking at what a mess we created of this. It's really remarkable that people get any work done. But the sort of the philosophical idea here is really that, or the way before these direct chunk functions were introduced, sort of the philosophy was always, H size T is an HDF5 API type, and as such, specific to the C API, if you wish, of HDF5, and it's not the C standard type. It's just something that's defined in an HDF header file. And typically, you would use H size T when you were measuring the size of something as an element count. So H size T 100 meant 100 data type elements, and that could be for a data set or for an attribute, depending on what the underlying data type was. And then, yes, an element of the underlying data type would have a storage size, and that could be storage in the file or storage in memory or something like that. But element count sort of ignored that storage size, if you wish. And then there was the other type of size measured in size T, the C standard type. And if you look at the APIs, except for these chunk-related things, I think the use was pretty consistent, and that you could rely on that. And there are also sized version of this. So there is H S size T and S size T. But I think we were pretty good about enforcing that discipline. But then, as Mark, I think in his post pointed out, we really made a mess of it. And then add to that library limitations at the moment, that chunks can be no larger than, I forgot, 32. I forgot already. There is an upper size limit on chunks at the moment in HDF5. And so, Dana, I think, chimed in to point out that something was made a 32-bit integer rather than a 64-bit integer and so forth. So we got to straighten that out. But then, unfortunately, as these things go with the API versioning and so forth, yeah, we will have to version this to just deal with this mess. And yeah, it's going to create more confusion for some and clean up the confusion for others, but it's not pretty. And I think the only thing we can try is have some kind of post-mortem and try to understand how did that happen? Who sort of thought that that was such a good idea, or maybe nobody was really thinking that was really maybe a case of somebody's asleep at the wheel. Anyway, any other questions, comments on that? No? Okay, good. Then the next one up, yeah, it's just, I think I would say it's community life in the HDF community is Mark, again, I think it's good for him to spot that. He noticed that there is this Z standard compression method. I think it was developed at Facebook or something like that. And then Andrei Paramonov developed a sort of a plugin interface for the HDF5 library, and Mark had developed a patch for that and submitted it to Andrei, who seems to have disappeared for whatever reason or didn't respond to it. And then I think Mark rightfully said, well, where do we go from here? I think there is a fair amount of Z standard users out there. And I think in this case, yeah, it is the plugin interface is not a giant piece of code. It's rather, I mean, it's just a few pages, 2 pages at best. I think a header file and a C file plus a CMake file and so forth. And yeah, so I think Alan already responded, who would be, I think, the best informed about how to deal with that. And I think, yeah, we can adopt this in some form, either as part of our filter plugin collection, or I think Alan described 2 different ways how we can go about it. But yeah, I think that's a good way. I think it's a good thing that people in the community speak up and say, hey, we have a problem here and let's try to solve this. And then, yeah, we will certainly try, if we can help, if it's not sort of a tremendous maintenance burden or overhead on our part, we will certainly try to help with that. Next one up, that was an interesting discussion. I think Wei King was asking, is there a way, he said, I'm creating all these contiguously laid out data sets in a given group, and is there something that I can do to do that in a way that the metadata portion of this, so to speak, the group that has the links to these data set is located somewhere in the file, and then more or less following that metadata section or region of the file, since all these data sets are contiguously laid out, how can I maximize my chances that these would then be laid out almost contiguously, but for sure at monotonically increasing offsets in the file after that metadata portion, and not be interleaved by group-related metadata. And I think he rightfully expects that that should give me a good read performance. And we had at least sort of 2 interesting suggestions, because in a way they are coming at this problem from different angles, but with the same effect. Elena was suggesting, well, what you could do is, if you want to make sure that the group metadata sort of drops in place first, what you can do is just delay the allocation of the data, of the space for these data sets by just passing an access property list to these data sets when you create them, by specifying, I think this H5P set alloc time call, where you can say H5D alloc time late, usually for contiguous data, for contiguously laid out data sets, the allocation time is early, meaning the moment you call H5D create, if it's contiguous, it will be file space will be allocated in the file right then and there. But then by telling the library you want late allocation, that will be deferred until the first write that occurs to that data set. And so, yeah, if you create all these data sets first and don't write any data to them, then you could, in a way, hope that the library would allocate first the group and then the local heaps and all the rest of it to store the links and so forth, and then put the data set past that. So I think that's an interesting approach, although, yeah, Elena pointed out that she had never tried this, but I think it's an interesting idea. The other idea, I think Mark suggested that you can certainly use this function H5P get meta block size to influence the growth of space set aside in the file for metadata. And by choosing a large block size there, just create enough room so that once you start creating all these data sets, you have enough space to store all the infrastructure, so to speak, for the group. And that way hope that then following that, the data sets will just follow it in the file. I would also maybe combine that with, there's a function called H5P set estimated link info. There are, that call might help with, I mean, I think it comes down practically to the same thing, the metadata block size here, but it's more, let's call it user oriented, in the sense when you specify the estimated link info, you are basically telling the library for a given group how many links you expect in that group and a typical length of link names in that group. And then as the combination of both, the library can say, okay, I hear 1,000 links and each link is 100 or 128 bytes long, then it can sort of, yeah, pre-allocate space for that, and it would have the same net effect as maybe H5P get meta block size. It would be actually interesting to know if you use both, because obviously the H5P get meta block size works for all metadata, not just group related metadata. But so yeah, I actually don't know what happens if you use both function, if there would be any kind of interference, or you might actually get better results or poorer results. I don't know. I haven't tried this, but I haven't in a thread. I want to later. I'm going to wait a few more days. But if Ray King had gotten a chance to actually try these things, and if he had seen any performance improvement with that's definitely something interesting to follow up on. Any questions on that? No. Any other questions before I continue here? No. Okay. No. Good. Then there was this discussion. Yeah, this is my understanding is this is some kind of engineering package, Nastran, and they use HDF5 files. And I think the user was somehow had discovered that these Nastran files are HDF5 files and opened them in HDFView, and then was sort of, I guess, as part of this Nastran package, you can visualize certain mechanical engineering structures and with like physical quantities that you might have, like stress contours, I think is the example that he used. And he was sort of missing. He said, well, I think he said something like, okay, now I can open it in HDFView, but all I see is a data grid. Where are my stress contours? And yeah, so I think the problem is that HDFView, the sort of the vanilla HDFView out of the box, is really it's a graphical user interface that lets you, using sort of visual metaphors, inspect HDF5 files. However, that is not a domain-specific visualization tool, or it's not even a visualization tool of any kind. And I think it's important to keep that in mind. Of course, yeah, the HDFView is a sad story in the sense that it's not gotten a lot of love and care, and that's as far as usability experience, UI quality and so forth goes. It's early century. I think Elena, not in this thread but in another thread, used the term beginning of the century, and it made me so just reading that expression made me feel funny. I thought that must be a long time ago, beginning of the century. And no, but it's interesting. I mean, we definitely recognize the need of a tool, of a modern version of a tool that can really be used to, again, graphically, as part of a graphical user interface to inspect the contents of HDF5 files, although nowadays I think people would also expect to look at HDF5 files in double quotes if they are represented by HSDS endpoints, because it's the same HDF5. I mean, there's not a physical file maybe on your disk, but as far as sort of the group profile and the attributes and all the rest of it goes, it is HDF5. It's just a different way of representing it in bytes or objects. And so it's on our mind, and yeah, we might do another over the years. We've probably done several surveys on sort of what people think of HDFView. I mean, obviously there are a lot of things that it can't do and so forth, but just to reestablish that there is a place for it beyond domain-specific visualization tools, like engineers, if they want to use ParaView or Visit or some of those tools. Those are visualization tools that work for a lot of domains. They are not necessarily domain-specific, but their bread and butter is to do visualization, in situ visualization, parallel visualization, and so forth. That's all way beyond the scope of what we had in mind with HDFView. But I personally think there is still a niche, and the better we can identify and delineate that niche to say where this is the place for HDFView, the better we can articulate that, then we can think about, well, how are we going to implement that? What is sort of a modern, relatively future-proof to the extent that it can be today, technology to maybe implement that. And yeah, but that's something. Staying on topic of HDFView, obviously, I mean, just in the, of course, I'm not reporting all HDFView related questions, but there were at least, well, there was one that we'll talk about in a moment, but I saw at least one or two other HDFView related questions. So obviously there is demand out there. And I was pleasantly surprised. I remember this thread when it began a few months ago, where someone had said, hey, wouldn't it be a great thing if we could make HDFView available on FlatHub? And lo and behold, there was a thread, and the user said, I use it. Okay, yeah, thanks, Martha. That it's available on FlatHub now, and I thought that would be a great opportunity because I can't give you much of tips and tricks today. Let's just try it, because the user, and I bookmarked it here, gave us instructions on how to do this. So here is here's a setup guide, and since I'm on Chrome OS here, I have Linux support enabled, and so I have a Linux shell here, so we can skip all that. And then, so let's see, I have not done that part, so that might of course fall flat on its face right away. Let's see if I can. I don't know how many dependencies. How many dependencies there are for Flatpak, but we will see. Okay, let's see. Oh, 39 megabytes. That doesn't sound too bad. So let's install it, and then we have to add the FlatHub repository, and then we should be able to install it. And hey, if this works as advertised, then we should be up and running with HDFView. And if it works, I will praise the work of this user on the forum. If it doesn't, then I'll report the error. But that's always a fun thing to try. So okay, we have FlatHub. Now let's add that Flatpak repo. Okay, that's done. And to complete, you can now, all you need is install some apps. Sudo apt install. Okay, how do I? Oh, quick setup, browse the apps. Because, okay, I didn't. Oh, then maybe all I have to do is do this Flatpak thing. So I'm just, this is live. I haven't really tried anything. So he says, let's shut this down. So that's what I'm going to do is shut this down. And I'm going to quickly shut down Linux just to make sure that the sort of the container infrastructure restarts. And then, okay, this is not it. Let's just start a new container. And here comes my new container. And then press search, launcher, type terminal, install Flatpak. Right. And then, let's see, maybe Flatpak dash help. Maybe there's, oh, Flatpak install application. So let's try Flatpak install, and then maybe I would hope this has a name. It's just called HDFView. Oh, here. See, I'm just showing my ignorance here. Oh, I can actually use this. Okay, do you want to install it? Yes, let's install it. Okay, what is that? Proceed with these to the user installation. Okay, these look like big ticket items, but we can see how long it takes. About a gigabyte, but then let's see. So maybe while this is going, and if the audio quality is not too bad, let's just leave this running and let's see what else we had. Oh, yeah. So we had a good discussion here around, somebody raised the issue using HSDS, basically saying this is something that's not specific to HSDS, that's also something we have with the regular HDF5 library, although on a different scale, is that, yeah, if you try to create a lot of small objects, then there is a certain overhead associated with that. And so this user noticed in the case of HSDS, where you use this RESTful API, that there is a lot of sort of round tripping going on, all these service invocations and so forth. And as we've discussed with John in the past, of course, the idea would then be, can you aggregate or combine many of these creation calls into an array of object creation requests? And if you've attended the Multidataset webinar, that's kind of along the same lines, the where you want to create or write to multiple data sets at the same time or read from. you can just sort of batch that up, and then the library can optimize on top of that. There is a similar strategy, representational straight transfer. Okay, I'll just bring this to an end, and then we'll check in with HDFView. Representational state transfer, where you have the HTTP protocol, the puts, the posts, the gets, and the infos and whatnot, and that's how you express your HDF5 calls, if you want, or requests. And but there is another interface, and I forgot which of the big companies developed this thing called GraphQL, where rather than sort of piecing together representations of resources in a web service interface, you have a service interface that really looks like writing down an expression where you basically can specify an array of resources and basically go to that service and say, give me this. And I think there can be regular expressions such as wildcards. If there are multiple resources of a given name, you can put a regular expression with star something in there, and then it will fetch or compose, the server will compose a response, including representations of all these resources in one go. And that's, of course, the idea that there is, for example, an issue, an improvement issue for HSDS in place, where we thought, well, maybe we can, if we can find sufficient interest in supporting GraphQL with HSDS, then that might be an interesting thing to be. And yeah, so we'll see where that discussion goes. Okay, let's check in with HDFView. So let's try to run it. Wow. Okay. It works. I mean, you know, okay, so this has to do with my formatting here, but this is HDFView. Let's take a look. It's HDFView. Okay, it doesn't tell us anything about versions, but it supports HDF4. Oh, HDF5 library version 1.12.2. Not too bad. And then let's see if we can open an HDF5 file. Let's see, home. Oh, here we go. And fortunately, I got tons of HDF5 files. So let's pick one of them, and it works. Great. Hey, I'm going to report that on the forum that we tried it live, and it works. And it's HDFView 3.2. I take it. That's great. And let's see, general info. Oh yeah, cool. Good. Hey. I wish our software was this good. Okay, so we can report. We tried live to install HDFView from FlatHub, and I think, yeah, some of the artifacts that the widgets, the windows were a little bit misshapen maybe, and so that, I think that has to do with Chrome OS, or with the it doesn't use X11, it uses Wayland, I think, on the Chrome OS, and that has some implications and whatnot. But great, it works. Now, okay, we are almost out of time. There was one more interesting issue, and I don't have an answer for that. Someone reported sort of an oddity in behavior with parallel HDF5. I believe the scenario was the user was reporting, okay, I have 8 ranks. I think he didn't specify the file system, so let's say GPFS or Lustre or something like that. And he was writing a data set from 8 ranks. He didn't say if he was doing collective or independent, but that's another story. But chunked, presumably, because he was talking about with compression and without compression. So let's assume when he says without compression, that means he still did the chunking, he just didn't compress the chunks. And then in one case, so if he does this uncompressed and he calls H5F flush, I think he said something, it took 70 seconds, order of 70 seconds. But then when he used compression, it took only 40 seconds. And then he reran it. So with compression and flush, it's important to point it out, with compression and flush, it took about 40 seconds. And then he reran the experiment and he ran it without calling flush, with and without compression, and also took only about 40 seconds. So there is this, and he, I think his question is there a difference in how H5F flush behaves, whether a data set is compressed or not? And I'm not sure. I don't have an answer. It looks odd, but yeah, I'll ask my colleagues to respond and to try to explain what's going on here. But and of course, he points out that, I mean, I personally, in my own application, I rarely have the need to call H5F flush, because typically the library does that for you. But there are situations where you might feel the need to call H5F flush, and he pointed it out. He said, yeah. Whether that's a good idea or not is a different discussion, but we see this behavior and it's not clear to me why that is. And anyway, but next time I hope we can resolve that mystery. And I think Dana is coming back from travel today, so I hope he'll be back here next time. And we are out of time, and thanks for coming. And yeah, so I hope for the next times we can find a little bit of a schedule or rhythm for our sort of star speakers, John, Alexander, Scott, Dana, and with slightly different themes, sometimes a little more HPC focused, sometimes a little more HSDS, sometimes a little more Pythonic or sort of the community, maybe earth science, maybe allotrope or something like that. And then Dana about general engineering questions and releases and the library and so forth. So stay tuned for that. Thanks for coming and enjoy the rest of your day.
Okay. Thanks, Gerd.
Yep. Bye.